This is SpaceTime Series 23, Episode 35. Coming up on SpaceTime, discovery of superluminal jets generated by colliding galaxies, the first ever observation of a rare helium white dwarf binary system, and final preparations underway for the launch of the Mars 2020 Perseverance rover. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered jets of charged particles bursting out at close to the speed of light from a pair of merging spiral galaxies. Previously, astronomers captured similar relativistic jets emerging from elliptical galaxies, but this is the first evidence of it happening from a pair of colliding spirals. The jets are being generated by material being pushed by the impending collision towards the centre of one of the galaxies. There, it falls into the galaxy's central supermassive black hole. As it does so, it forms an accretion disk around the black hole's event horizon, with the materials being crushed and ripped apart, releasing vast amounts of energy before eventually finally disappearing into the black hole. The energy is being focused into powerful gamma-ray jets, bright enough to be seen across the universe. It's usually pretty hard to dislodge material embedded in a galaxy and then force it towards the galactic centre, but a collision with another galaxy is a pretty good way of doing it, moving enough material to generate extremely bright jets in the form of quasars, blazars, and radio galaxies, which are actually all the same thing, active galactic nuclei. It simply depends on their orientation. The findings, reported in the Astrophysical Journal, suggest that the young age of the jet, which has been named TXS 2116-077, has allowed the authors to actually see the galaxy that's generating it. The study's lead author, Videli Pallier from Clemson University College, says the jet's not powerful enough yet to blind observers and hide the host galaxy from view. Usually, these jets can emit more energy in the form of intense radio waves, X-rays and gamma rays in a single second than our Sun will produce in its entire lifetime. The image of the two merging galaxies suggests they're probably colliding for the second time based on the amount of gas that's already been dislodged. Now, eventually all that gas will be expelled into space, and without gas, those galaxies won't be making any more stars. While it's now believed all galaxies have centrally located supermassive black holes, not all of them are feeding, and so not all of them have active galactic nuclei. For example, our own galaxy, the Milky Way's supermassive black hole, Sagittarius A star, appears to be mostly dormant. This is SpaceTime. Still to come, the first ever observation of a rare helium white dwarf binary, and Comet Borisov, the solar system's second confirmed interstellar visitor, appears to be breaking apart. All that and more coming up on SpaceTime. Okay, let's take a break from our show for a word or two from our sponsor, The Great Courses Plus. With all that's going on in the world now, I'm so grateful for The Great Courses Plus. This amazing streaming service is proving to be an incredible resource, not just for me, but also for our entire team. Well, helper. Hello, Hugh. One of the things we've really enjoyed during this unusual lockdown time is how it keeps us entertained and educated, distracting us from that constant bombardment of negative news stories, which seem to pervade all the media at the moment. It's refreshing and stimulating at the same time. The Great Courses Plus provides the space to continue exploring the world while still staying indoors, keeping our brains active and engaged. And of course, there's so much you can learn, a course for every curiosity. From hobbies like playing the guitar, practicing yoga or performing magic tricks, to the classics like history, literature and science. As I mentioned last week, I've been checking out a course called What Darwin Didn't Know, The Modern Science of Evolution. Now, as you'll learn in this course, evolution isn't just possible, it's inevitable. The course examines the sorts of questions that have been answered since Darwin's time. What led to mass extinctions? Why humans age? What gene editing's all about? And much more. In fact, there are 24 lectures in all. And you can watch or listen any time through the Great Courses Plus app. You can even stream the videos to your TV and watch as a family, keeping the kids learning while they're out of school. In fact, the Great Courses Plus is a great supplement to education for any age. And of course, we have a special offer to get you started. How about a free trial plus 50% off the regular price when you sign up for a quarterly plan? So, sign up using our special URL to get started, thegreatcoursesplus.com. thegreatcoursesplus.com/space. That's thegreatcoursesplus.com/space. And as usual, you'll find the URL details in the show notes and on our website. That's thegreatcoursesplus.com/space. And now, it's back to our show.
This is SpaceTime with Stuart Gary.
Astronomers have for the first time ever detected a rare helium white dwarf binary system. As we mentioned earlier this week, stars shine by fusing hydrogen in their core into helium. When these stars run out of hydrogen, that balancing act between the outwards push of nuclear energy and heat and the inwards push of gravity ceases, and gravity's the winner, causing the star's core to dramatically contract and compress. And as the star's core contracts inwards and heats up, that heat pushes its outer gaseous layers further outwards, causing the star's outer envelope to expand. And with the star's visible surface now being further away from the core than what it was before, it gets cooler and it turns more red. It becomes a red giant. Meanwhile, that inwards compression on the core of the star increases pressure and temperature, eventually getting hot enough to ignite helium in the core, causing that to begin fusing into carbon and oxygen. Now, ultimately, the helium in the core will also run out, just like the hydrogen did before it. But because Sun-like stars don't contain enough mass to cause carbon and oxygen to fuse into heavier elements, the star dies. The dying star's outer gaseous envelope begins to separate from the core and gradually floats away as a planetary nebula. And the now exposed white-hot stellar core, called a white dwarf and about the size of the Earth, is therefore left to slowly cool over the eons of time. This is the future we can expect for our own local star, the Sun. This binary helium white dwarf system, which astronomers have observed, catalogued as J2322+0509, is the first such system ever detected. A report in the Astrophysical Journal claims the two stars in the system are orbiting each other every 1,201 seconds, just over 20 minutes, and that's the third shortest orbital period of any known detached binaries. Any closer, and they'd be sharing their outer envelopes. The study's lead author, Warren Brown from the Harvard-Smithsonian Center for Astrophysics, says this system is at the very extreme end of stars with short orbital periods. And the orbit of the pair is decaying. The gravitational waves that are being emitted by this pair are causing them to lose energy. And in 6 or 7 million years' time, they'll merge into a single more massive white dwarf. This binary is the first gravitational wave source of its kind ever detected. Brown says theories predict there are many more double helium core white dwarf binaries out there, and this detection provides an anchor for those models, and for doing future experiments so that astronomers can find out more about these stars and determine their true numbers. The system's also good because it can be used as verification for the much-anticipated LISA, Laser Interferometer Space Antenna Gravitational Wave Observatory. LISA is slated for launch in 2034. And verification binaries such as this are important because if LISA is working properly once it's placed in orbit, it should be seeing them within a few weeks of turning on its telescopes, or in this case its mirrors. Problem is there are only a handful of LISA verification sources out there at the moment, so this new discovery will help things along. Mind you, this particular helium core white dwarf binary is presenting a few problems, mostly because its optical light curves have yielded no results. Brown says his team couldn't detect any photometric signals because there aren't any. Spectroscopic studies, however, have revealed its orbital motion. To find out more, Andrew Dunkley is speaking with astronomer Professor Fred Watson.
Astronomers have detected the first double helium core white dwarf gravitational wave source. What on earth is that? I mean, I'm very confused.
Well, I'll confuse you more because its name is J2322+0509.
Yeah, okay. Great. That tells me a lot.
Helium core white dwarfs are a sort of species of white dwarf stars. White dwarfs are the end product of stellar evolution for stars of around the mass of the sun. So when the sun runs out of fuel, its core will wind up as a white dwarf star. And it's basically a cinder. It's hot. In fact, they're very hot indeed. But they gradually cool down because essentially nuclear reactions have stopped, although their atmospheres still at some level have nuclear reactions. Now, there is a category of these things which are at the low mass end. If I remember rightly, they're kind of half a solar mass or something like that, which are called helium core white dwarfs. And that comes about because of the remaining nuclear fuel that there is left in this white dwarf. It's still a cinder at the end of its life compared with something like the sun, but it's got stuff happening on it. So these have been predicted. And I think there's another theoretical prediction that suggests that they occur in what we call binaries, in other words, in pairs, one orbiting another. Many, many stars do that. In fact, it may even be as high as 50% of all stars are members of binary binary systems. It's a lot. It's a high number. It might not be quite that high, but it's something like that. So there's always been a prediction that you would expect to find these helium core white dwarfs orbiting around one another. And that's why this story has hit the headlines, because now astronomers have found one. And intriguingly, they found it because of its gravitational radiation. So this comes about because of, the detectors that we now talk about, the LIGO in the United States, Virgo in Italy. There is, I'm not sure how many more have come online. I think there is another one online already. I should check that up. But we now have this sort of mini flotilla of gravitational wave observatories, which are routinely scanning the heavens for gravitational waves. And if you've got two very massive objects, something half the mass of the sun, and two of them close together orbiting around one another, then they're going to emit gravitational waves. And that's what's been found. What has intrigued the scientists who've done this work is that you'd expect if you had two stars orbiting around one another, that would become what's called an eclipsing binary. One star passes in front of the other, and so the total light dims because you're only seeing the light of one rather than two. But that doesn't happen in this case, and it's because the plane of the orbit is at right angles to our line of sight. In other words, we're seeing them, basically projected against the sky. One's orbiting around the other with no eclipses. One doesn't pass it in front of the other one.
Both always within our line of sight.
Both always within our line of sight. That's exactly right. So there's no change in brightness. However, there's enough of a tilt that you can actually find a radial velocity, which means a speed towards or away from us. And using actually the what's called the MMT telescope. MMT used to stand for multiple mirror, but then they replaced, I think it had 7 small mirrors, a bit like the Giant Magellan telescope will have, except much smaller. But those were replaced by a single mirror a number of years ago. So I'm not quite sure what MMT stands for now, but it's still called the MMT telescope. It's a bit like the AAO, which is no longer Anglo-Australian Observatory or Australian Astronomical Observatory, but Australian Astronomical Optics. Keep the initials and
just change the name.
Change the name. That's right. Yeah. So that's been confirmed as a binary, but it's the gravitational waves that are the real, perhaps inspiring part of this story, that we're actually finding things that were predicted, but finding them by the fact that they're revealing their gravitational signature as they orbit around one another. It's astonishing stuff. So most of the gravitational wave detections that we've talked about have been merging objects, merging neutron stars or merging black holes. And that's when the two things are the sort of end of this dance around each other, and they coalesce and become a single object. Well, this is also going to happen to the white dwarf pair as well, but not next week or the week after. 6 or 7 million years they're talking about the merger between these two objects to form a single, more massive white dwarf star.
How difficult is it to tell the difference between various gravitational waves? And they're all caused by different things.
Yes.
So how do you know which is which?
That's the clever bit of all this, because there's gravitational waves have got a very specific signature depending on the masses of the object, their separation, other physical parameters. It can be modelled very accurately. You're right that there will be some uncertainty, but the traces of these gravitational waves, and you can see the structure in them. You can see how they change over time, particularly the ones with black holes merging. The gravitational waves, when you look at the period and the amplitude of the waves, and the structure within them, you can basically tell what it is you're looking at, which is extraordinary. But it's not like looking through a telescope. Oh, yes, that's a star, that's a planet. There's a lot of computation involved. But the astrophysicists who do this work are pretty confident in what they're seeing. And it all is self-consistent as well. The observations seem to be telling all the same story. And I should have said that one of the co-authors, I think, are in the United States. Yes, CFA, which is the Harvard Harvard-Smithsonian Center for Astrophysics, and the University of Oklahoma. There's a co-author from there. So one of the things that has been highlighted is that this is the kind of source that the LISA orbiting gravitational wave observatory will be able to detect and will actually be able to analyze perhaps in more detail. So these astrophysicists are saying that the star will be used for verification on the Laser Interferometer Space Antenna, that's the LISA, which is planned for launch in 2034.
Wow.
That is forward thinking.
It is rather, isn't it?
It's a very ambitious project. You might remember there was, I think it's about 4 years ago, there was a pilot version of LISA launched by European Space Agency, just one component of it, just to demonstrate that it will work. And they had results which were really stunning, absolutely above expectations. So the prospects for LISA itself seem really good.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is SpaceTime. I'm Stuart Gary. Still to come, Comet Borisov, the solar system's second confirmed interstellar visitor, appears to be breaking apart. Or is it? And final preparations underway for the launch of NASA's Mars 2020 Perseverance rover. All that and much more still to come on SpaceTime. Comet Borisov, the solar system's second confirmed interstellar visitor, appears to be breaking apart. New Hubble Space Telescope images show that Borisov has now become two distinct components. But unlike Comet Atlas, which, as we pointed out earlier this week, is disintegrating, Borisov may just be losing chunks of its nucleus. Because the cometary nucleus is composed of lots of volatile ices, when bits break off, it exposes fresh ice, which then fizzes and sublimates, releasing lots of dust. And it's that dust which the Hubble Space Telescope is actually seeing. So it's highly likely that it's just a little fragment that's broken off, rather than the whole comet breaking apart. Then again, it could just as easily be the whole comet breaking apart. Astronomers won't be sure until they can determine just how fast that second segment is moving away from the primary segment and how long that second segment remains observable. If it's there for a long time, then chances are the comet is breaking apart. But if it sort of fizzes out and disappears pretty quickly, then that means it was really only just a small piece breaking off. Comet Borisov was first detected in August 2019 and reached perihelion, its closest orbital position to the Sun, in mid-December, before continuing on its merry journey out of our solar system and back into interstellar space. While comets usually break up close to the Sun, when volatile gases are building up pressure due to the Sun's heat, it's not unheard of for cometary breakups to occur much later, in this case 4 months later. You see, sometimes it can take a while for pressure from volatile material inside the comet to reach a pocket of even more volatile ices, causing a sudden blowout. Another possibility is that as comets heat up during their approach to the Sun, they experience significant asymmetrical mass loss, and the resultant conversion of angular momentum causes them to begin spinning faster. And over several months, that spin-up can be enough to cause bits to fly off. Borisov is only the second known interstellar object to be identified in our solar system. The first was the asteroid Oumuamua, which was already on its way out of the solar system when it was first identified, giving astronomers little time to study it. This is SpaceTime. Still to come, final preparations are continuing for the launch in July of the Mars 2020 Perseverance rover. And later in the science report, studies show the COVID-19 virus affects the brain and nervous system in around a third of cases. All that and much more still to come on SpaceTime. Final preparations are continuing at the Kennedy Space Center in Florida for the July launch of NASA's Mars 2020 Perseverance rover. Over the past week, the assembly, test and launch operations team have completed some important milestones, fueling the Sky Crane descent stage and attaching the Mars helicopter, which will be the first aircraft in history to attempt powered controlled flight on another planet. Some 401 kilograms of hydrazine monopropellant have been loaded onto the descent stage's 4 fuel tanks. As the aeroshell containing the descent stage and the rover enters the Martian atmosphere on February 18, 2021, that propellant will be pressure-fed through some 37 meters of stainless steel and titanium piping into 8 Mars landing engines. The engine's job will be to slow the spacecraft, which will be travelling at around 80 metres per second when it's some 2,200 metres above the ground, down to just 3/4 of a metre per second when it's around 20 metres above the ground. While maintaining this rate of descent, the stage will then perform the sky crane manoeuvre, during which nylon cords will spool out to lower the rover 8 metres below the descent stage. Then, when the rover senses touchdown at Jezero Crater, the connecting cords will sever and the descent stage will fly off to avoid crashing into the rover. After the descent stage refueling was completed, the system that will deliver the Mars helicopter to the surface of the red planet was integrated into the rover. The 1.8 kilogram helicopter is equipped with 1.2 metre diameter propellers cocooned within a special delivery system. In one of the first steps in the day-long process, technicians and engineers made 34 electrical connections between the rover, the helicopter and its delivery system on the rover's belly. After confirming that data and commands could be sent and received, they attached the delivery system to the rover. Finally, they confirmed the helicopter could receive its electrical charge from the rover. See, before being deployed onto the surface of Jezero Crater, the Mars helicopter will rely on the rover for all its power. Afterwards, it will generate its own electrical power through a solar panel located above its twin counter-rotating propellers. The helicopter will remain encapsulated on the rover's belly for the next year and will be deployed around the beginning of May, roughly 2.5 months after the rover's landing. Once the rover's driven about 100 metres from the touchdown point and the helicopter's undergone extensive systems checks, it'll execute a test flight campaign lasting up to 30 days. Based on the current Mars Curiosity rover, which is exploring Gale Crater, the 1,025 kilogram Perseverance rover will search for signs of past microbial life. It'll characterize the planet's climate and geology. It'll collect samples for future return to Earth, and it will pave the way for human exploration of the red planet, slated to start in just over a decade. The Mars 2020 Perseverance mission has a launch window running from July the 17th to August the 5th, flying on an Atlas V rocket from Space Launch Complex 41 at the Cape Canaveral Air Force Station in Florida. This is SpaceTime. Still to come, the science report, and a new study has found that COVID-19 affects the brain and nervous system in around a third of all cases. And reports that going to bed early and following a consistent bedtime routine may help kids reduce the risk of becoming overweight or obese. All that and more still to come on SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has found that the COVID-19 virus affects the brain and central nervous system in around a third of all cases. The findings, reported in the Journal of the American Medical Association, are based on a study of 214 patients with the COVID-19 virus from the Wuhan province epicenter in China, where the disease began. Researchers found that in more severe cases, nearly half of all patients suffered symptoms including dizziness, headache, impaired consciousness, a lack of blood flow to the brain, slurred speech, stumbling, falling, a lack of coordination, seizures, losing one's sense of taste and smell, impaired vision, nerve pain, and even muscle injury. Meanwhile, a study has found that people with chronic obstructive pulmonary disease and people who smoke may be at greater risk of experiencing severe symptoms of COVID-19. The findings, reported in the European Respiratory Journal, suggest that both groups have higher levels of a molecule called ACE2 in their lungs, which acts as an entry point for the virus to cause infection. The study also found that former smokers had similar levels of ACE2 to people who had never smoked. A new study has found going to bed early and following a consistent bedtime routine may help reduce a child's risk of becoming overweight or obese. The findings, reported in the journal Acta Pediatrica, studied 1,258 Indigenous Australian children with an average age of 6. Researchers found kids who consistently went to bed late experienced greater weight gain over several years than those who went to bed early. The idea that cannabis isn't addictive still floats around among enthusiasts, but a new Canadian study may end up sending that myth up in smoke once and for all. A report in the Journal of the American Medical Association brought together all the best existing evidence around cannabis withdrawal, including 47 studies covering a total of 23,000 people. It found around half of regular users who tried to quit ended up suffering symptoms of withdrawal. Researchers found that male cannabis users and people who also smoke tobacco were the most likely to suffer withdrawal symptoms. And the more cannabis people smoked, the more likely they were to suffer withdrawal. Symptoms of cannabis withdrawal include irritability, anger or aggression, nervousness or anxiety, sleep disturbances, appetite or weight disturbance, restlessness, depression, and somatic symptoms such as headaches, sweating, nausea, vomiting, and abdominal pain. Meanwhile, as more countries around the world legalize cannabis for medical or recreational use, another study in the Journal of the American Medical Association claims we can expect to see a rise in the number of users suffering from psychotic episodes. The research by UK and Australian experts in a Viewpoint article warns that the available evidence suggests a clear link between using high-potency cannabis and an increased risk of psychosis. It says one solution might be to consider controlling the potency of cannabis available if they plan on legalizing the drug. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.